Alright, now we are going to write the PLC algorithm, and the task is to buffer the RFID information from the tags along with the timestamp. So if you see, if I bring the tag next to the RFID read-write head, it should read the tag information and store in the PLC DB along with timestamp, along the moment when it reads the tag. That's the timestamp we also want to store in the DB. So it consists of two parts. One is the timestamp, one is the RFID information. RFID information we already have in the RFID DB, which we are reading already in our PLC program, which we have seen here. Okay, and now we have to work with the timestamps. All right, so before we move ahead, I would like to change the start value because I am always reading the RFID information in this case. So I would prefer to change this to 1 so that every time I downloaded the PLC program, it should move 1. Oh, why it is not writing? Yeah, now I will just download it again, because in this case we are only reading the RFID information, we are not reading UID, and I want to make sure this startup with value 1. So it has 1 here, so just to check it is reading the information, RFID always. All right, now we have to work with the timestamp because we need to move the time as well. So how we can do that? So we need to make some logic. So in the RFID, I will make a new block. Let's take a function block and let's call it logic, and that I will take FPD. Okay, so we have a new function block logic. Okay, now in the logic we have to first read write timestamp. Okay, let's type it like this. Now if you see here in your extended instruction, if you go to date and time of day, we have two instructions: set time of day, read time of day. So let's take both of these here. So I will take write system time and read system time. So I have these two blocks here. Now why do I need write system times? In case if your system time is not correct, you can change it using write, and you can read system time again in a data register somewhere if you want to store. Okay, now for that I would like to take a logic DB. So I will take a new block, and because I need to store the time, I will write logic DB. Okay, now that's my logic DB. I will minimize that. Okay, now we need to put some values here. Okay, so I will define some tags. Let's say parameters, and let's make it struct because this is just for the time, and write here current time, and let's define this time with the data type DTL. This is date time. Okay, so you can find there automatically you have year, month, day, weekday, hour, minute, second, and nanosecond. So that's my current time, and similarly I need set time. That's also DTL, and I also need reset time. I will tell you why do I need reset. Set time I need for setting the value here. So if you see the set time, I can just put it here. So whatever time I want to set, I will put here, and I have to enable this to move this time to your system time. So to enable this, I need a trigger. So here I can write set time trigger. So this will be Boolean actually. So set time trigger will come here. So when this trigger bit is true, it will move the set time, which is here, into the PLC time. Okay, and return value is basically the status, which comes the status will show if there is any error in that or not. You can also see the help file, so you will find the information. So I will write here, this is write, so I will write write time status, and the status is basically integer. Okay, so this will come here. And now coming to the read time, this is the return value, this is again the status. So I will write read time status, and the status will come here. Now whatever time it will read from the PLC, it will store in some tag, which will be my current time. So it will come here. Okay, so this will be executed all the time, so I will not make anything enable. So it will just read the time which is stored in the PLC and store that time in the current time. So current time will be the time inside the PLC. Set time is if I want to change that current time, I will set this time here, and automatically this will write to the PLC, and this will read from the PLC, and which will reflect the time here. Okay, so this is basic. So let's just try these, just the time parameters, and see if it is working. So I will download, load. This is just to read and write the system time, so it should not be that difficult. I will go online, and if you see here, currently my current time is not actual current time. This is showing 0. Okay, one thing I forgot, I have to call this in my main logic, that's why it's not working. So maybe let's go here, another network logic, and let's call it here. So don't forget, you always have to call your logic in your main program. That's how it will work. Okay, so now I will download again. Oh, wait a second, it has made a TB. Anyways, just download it. Okay, now it's downloaded. Now you can see that the current time is here. So that's the current time which is being read from the PLC. If I go to online here, so this is reading the time from the PLC, and you have the time here. So this is pretty much same as my current time, which is 2 o'clock in the evening, 2:14. Yeah, 14. This is the date, 19 April, 14:15. Oh, just 1 minute difference, but that's okay. So if you want to set this time, you can set this time here, and that will be moved to your current time if you trigger this bit. But we don't need it. I'm happy with this time. This is just for explanation. So you have your current time here. Now why we need this time? Because we need to move this time. We need to move this time in our PLC DB along with RFID information. Okay. And you will only use write time if your current time is false. That's the only reason why we need that. So this was the logic just to get the time, the current time in our PLC. In the next video, I will make another logic to move RFID information and the time in another tags or another DB. All right. So see you in the next video.